In this session, we will discuss everything about isothermal and adiabatic process. Okay, this is the curve for isothermal and adiabatic process. Here we see that P into V is constant. That is Boyle's law holds for isothermal because temperature is constant. And for adiabatic process, PV to the power gamma is constant, where gamma equal to Cp by Cv. And we see that the slope of adiabatic curve is gamma times that of isothermal curve. So we can see that adiabatic curve is steeper as compared to isothermal curve. And the work done, if we see, then work done for isothermal process is higher as compared to adiabatic process because work done is nothing but the area under the PV graph. Okay, अभी हम दो तरह से इसको डिस्कस करेंगे. One is reversible, other is irreversible. Okay, now whether the process is reversible or irreversible, these three conditions will prevail. So for isothermal, there is no change in internal energy because temperature remains constant. So whether it is reversible or irreversible, delta U will be 0. Now for adiabatic process, there is no heat exchange between system and surrounding, so Q equal to 0. And then your first law of thermodynamics says that delta U equal to Q plus W. So as delta U is 0, so Q will be equal to minus W. Okay, and the temperature remains constant, so T1 equal to T2. Okay, so if it is reversible process, then T1 equal to T2 throughout the process, and if it is irreversible, then T1 equal to T2 at start of process and at the end of process. Okay, now let us see adiabatic. Here Q equal to 0, so first law of thermodynamics says delta U equal to Q plus W, so delta U will be equal to W. As the work is done by the gas, so we can say that W will be negative, so we can say that delta U will be negative and the temperature T2 will be less than T1. Okay, now work done for isothermal is given by minus nRT ln V2 by V1. अगर हमें कभी क्वेश्चन में टेम्परेचर और नंबर ऑफ मोल्स नहीं दिए हुए हैं, then we can say minus P1 V1 ln V2 by V1 or P2 V2 ln V2 by V1. Okay, now work done for adiabatic, we see that W is equal to delta U. So and delta U for ideal gas is given by NCV T2 minus T1. So work done is also NCV T2 minus T1. CV can be written as R upon gamma minus 1. So it will be NR upon gamma minus 1 into T2 minus T1. And sometimes your number of moles and temperature are not given, then we can write nRT2 as P2V2 and nRT1 as P1V1. So this will be the formula. Okay, now for irreversible process which take place very fast and which take place under constant external pressure. So work done is given by minus P external into V2 minus V1, whether the process is isothermal or adiabatic. Okay, and the conditions 1, 2 and 3 are common for this reversible as well as irreversible. So this is how we complete our discussion. Thank you and wish you all the best.